Okay, so last time it was like small 3 questions. The first one is how do we create an abstract class in C++? I received like a mix of answers, maybe like 6 of them were correct and the rest were wrong. An abstract class in C++ is created by having at least one pure virtual function. And to have a pure virtual function, you basically declare it, but you do not define it. You put it equal to 0. Let's say this is a virtual function. Is this an abstract class? Can anyone tell me if this is an abstract class or not? Okay, someone is saying yes. Well, it's not an abstract class because I have a virtual function, but it's not pure virtual function. This is a declaration of the function, and this is the definition of the function. I'm defining what the function is. It is virtual, but it is not pure virtual. In other words, I can create an object of this example class. I'm allowed to do that. It is not an abstract class because everything is defined. Even if I have virtual functions, it means when I inherit from this class, I can override them. But the class by itself is not abstract. It is well defined by itself, even though the function does nothing, but it is defined. For this to be an abstract class, this has to be a pure virtual function. It means we put it equal to 0, and we don't have a definition for this function anymore. It is just a declaration, meaning that this class example declares a function of type, returns a type void that is called test. It takes no arguments, but we don't know what the hell tests do. So we cannot create an object of the example class by itself because it's telling us object of abstract class type example is not allowed. The function example test is a pure virtual function. This is pure virtual, so we have no idea what it's supposed to do, so we cannot create an object of it. Why do we use abstract classes? Because by itself, it might be meaningless. For example, animal. Let's say we have class animal and function make sound. I think we did this example last time. So any animal does not really have a specific sound, but if we inherit from animal, cat, we inherit from animal. Now we can define the virtual function. Actually, last time we discussed also using the term override. So make sound. Override, and then we can define it. So now we are defining this make sound function. If we don't want to use override, we can still do this. As long as we've defined the base class function as virtual, then everything will follow. If it has the same exact declaration, it will be also a virtual function, but it's a better practice to write it down. Unless you're writing the override, then you don't have to. Now, we cannot create an object of animal because it's an abstract class. An abstract class in C++ means that it has at least one pure virtual function. A function with declaration, a virtual function with declaration, but without a definition. It's equal to 0. It doesn't mean that all its functions have to be pure virtual or even virtual. Like we can have just another function print, and we can define what it does, etc. And this will be a normal function, but this will still be an abstract class because there is at least one function that is pure virtual. However, we can create an object of cat because cat is well defined now. Cat inherits everything from animal. which includes the make sound function and the print function. And it is overriding the make sound from the animal class, and it is defining what happens inside of it. So now the cat class becomes a concrete class. It has everything to be able to use it, basically. Is it clear about abstract classes and how to create an abstract class? Okay, if anyone have any questions, please ask me now, because I'm sure these questions will be on your midterm, and I'm sure that you need to practice these to understand the concepts behind everything and to continue with this course as well. If you're not practicing well at this point, don't expect that you'll be able to learn everything one night before the midterm. Okay, the next question was saying that we have a base class with a virtual function called print, and a derived class that inherits from the base class and overrides the print function from base. And then we create a pointer of type base that is pointing to a new derived object. So we're constructing here a derived object that is being pointed to by the base pointer. So this is a pointer of type base pointing to an object of derived class. And then we are calling print on the pointer base. And the question is the print call happening on the base or derived class? This is happening on the derived class. This is the whole idea of polymorphism. Because it's a pointer, it's happening on runtime, in which the program is deciding which print function to make the call to. And because we have an override to the print function from base inside the derived, and we have a derived object here, it will make the call to the derived one. And this decision is happening on runtime and not at compile time. The memory is on the heap in this case. The program, the compiler doesn't necessarily know what's on the heap and doesn't know what decisions to make. On runtime, the program will be checking, does derived class has a function called print? If it does, it's going to use that print. If it doesn't, we might inherit from base class, but not override the print function. So if it doesn't have the print function, then the program will go one level up in the hierarchy of inheritance and will check, does the base class have a print function? Yes, I'm going to use that one. So answering these questions, in this specific case, the print in here is made a call on the derived class. Like this is the print of the derived scope and not the base class scope. And the decision is happening on runtime. Any questions? Okay. So we're gonna move on to operator overloading today. I'm going to delete these. So I'm gonna start with a simple class that represents a linear equation. So let's say class linear equation. And by linear equation, I mean ax plus b, equation of a straight line, basically. So I have public and private stuff. And the private, I will have two doubles a and b, which will represent the linear equation. And that should be it for our private members. So an object of a linear equation will be represented by the two doubles a and b, which is really this equation here. Now for the public, we're gonna start with a, let's say a constructor. So linear equation, it takes double A and double B. And I'm gonna put the double B by default equal to 0. Just for like we'll see later why I'm making this example. So double B is equal to, this is a default argument basically, putting it equal to 0. And we're going to initialize A and B using the initializer list. If you still have no idea what the hell I'm doing, go practice. So this is a simple regular constructor in which we're initializing A and B for this linear equation. B has a default value of 0. In other words, I can create an equation by just passing one parameter, which will mean that this is A is a value of 1 and B is a value of 0, which makes it a straight line with a slope of 1. Anyone that does not get this class and what it's supposed to represent? Okay. Let's also add a maybe default, if you want. Default constructor. We'll initialize the A to 1 and the B to 0. And this is just a default constructor. Well, it's a linear equation, so x is a variable. When you have a straight line function or equation for a straight line, it is represented at a times x plus b, where x is a variable. So this class is representing a linear equation, and x is a variable. So later on, we can evaluate this function. If you want, let's do it right now. Let's add a function called evaluate, which takes a double for x. So we pass to it x, and we do the actual calculation, return a times x plus b. So this is our a and our b, and inside the object of the linear equation, and we pass x, and it will evaluate the y value. Which, if you have a straight line with this equation, you will pass the x value, it will return the y value in this example. So let's say evaluate 4. Well, because we allowed it to create a default value for b, and here I'm passing a default value of b. So when you're having a default argument, if I don't pass one, it will take the default value, which is 0 for b in this case. So obviously I cannot do just evaluate. The equation dot evaluate 4. Let's print this value. The value we should be getting is 4 as well, because we have like a slope of 1. And we have the output of 4. So things are working so far. Now, what happens if I do, let's say I have another equation here. Call one F and call the other one G. And this has a slope of 2 and B of 3, for example. And I am doing F plus G. Let's say I have another linear equation. Result equal F plus G. Now, what I'm getting here, I'm getting an error, obviously, for the plus. It says that there's no matching for this operand. The compiler have absolutely no idea what do I mean by adding an object of linear equation to another object of linear equation. But you guys should have an idea. What should happen in this case if I'm adding a linear equation to a linear equation? This is represented as basically 1 times x plus 0, and this is represented as 2 times x plus 3. And if I'm adding these two, what should I get? Three x plus 3. It's just adding like simple linear equations. So we're going to tell the compiler basically what do we mean by adding or using the plus operator between two objects of linear equation. Because at this point, the compiler have no idea. So inside our class here, we're going to start doing that. So we'll have our operator will return an object of linear equation as well. We type the term operator. Whenever we're overloading an operator, we specify operator, and then we specify which operator it is. And then, so here's the thing. There's two ways to overload an operator. One that will be an operator that is part of the class, like a member of the class, and another one which can be a global operator in which we specify what's on the left side and what's on the right side. So in this case, I'm defining this operator as part of my class. It's a public member of my class, which means the left side of this operator will be the object of my class itself. Like simply when we dealt here with the function evaluate, I'm dealing with A and B. I'm dealing with this object. Like I can also use the this operator, which or this keyword, which has the which is basically referring to the object I am in right now. And such operator here, which is part of my class, will be doing things on my object. So I can refer to A and B directly as the object I am calling this operator on, which is on the left-hand side, which in this case would be the F. So the F will be the one that I am inside right now, which means for this operator, I need to pass the right-hand side, which in this case will be an object of linear equation as well. So in here, I'm going to pass this object as a constant reference, because I don't want it to make a copy of it, and I'm not changing the G here. So I need to make sure it's a constant reference, because I don't want it to change the G. I just want it to read it. And let's say we have, we can pass, so this will be the right-hand side. F is our left-hand side, which is the object we are in, and this would be the right-hand side. You can call it right-hand side equation if you want. And now we want to define what happens, like what do we return here? So let's return an object of linear equation. For the A, what we will pass for the A will be the A of my class, or of my object right now, plus the A of the right-hand side. I'm adding both A's. And for the B, I will have the B of the object I am in right now, which in this case will be the F, plus the right-hand side equation B. So this will return a new linear equation object, which has basically it's adding the A's together of the object of the linear equation I'm in right now with the one on the right-hand side, which in this case it is the F plus the G. So it is 1 plus the 2. And for the B value, I'm also adding the B's from the one on the left with the one on the right. And now this here will define what an operator plus will mean for a linear equation that is taking a value, like basically the left-hand side is an object of linear equation, because this is what we are passing to it, or this is an operator on the class itself, a member of this class. So the left-hand side will have to be an object of linear equation. And the right-hand side, we're declaring that it is of type linear equation and it's being passed by constant reference. Now, because we've defined what we mean by a plus operator with these left-hand side and right-hand side, now the compiler knows what to do with this part here. It is able to evaluate f plus g. And this operator here is returning a linear equation object, which we are constructing here, and it's returning it, and it is being assigned to this result object. Do you guys have any questions so far? I can run evaluate on result, let's say at 1. What should I expect as an output? Six, because the result should be 3x plus 3. If x is 1, then it should be 6. And I do see an output of 6. So my addition operator is working, which is nice. Okay, if any of you did not get what we did right now, just let me know before we move on to more advanced stuff. Okay, we can do the same thing for the minus operator. It will also take the right-hand side to be a linear equation by constant reference. And what we are returning in this case is a minus right-hand side dot a, and b minus right-hand side dot b. Very similar thing. We're just subtracting the a's and subtracting the b's and constructing a new linear equation and returning that when this operator is calculated on two objects of linear equation. Okay, now let's do the multiplication. Similar syntax, we specify which operator we want to overload. Because this is a member of our class, so the left-hand side will be an object of linear equation that we are basically calling this operator on. And we have to pass the right-hand side, which will also be, in this case, a linear equation constant reference to a linear equation object. And now how do we multiply linear equations? We basically multiply the A by the A and the B by the B's. No, we don't do that, do we? I was waiting for someone to tell me I'm doing something wrong. So how do we multiply two linear equations? Let's look at this example. We have x plus 0 times 2x plus 3. Let's say this is plus 2. So 1 times x plus 2 and 2x plus 3. Okay. So we have multiplied by A and then B prime A double prime X plus B prime and B double prime, which if we factor the X, we'll get A prime A double prime plus A prime B double prime plus, actually I have an X square here. What am I doing? This should be X squared. Okay, multiplying linear equation would be wrong to do it in this case. We'll have to return a different maybe class, which is not a linear equation, or we'll have to find a different design because we cannot necessarily store X squared in this representation. So we're gonna skip multiplication. You can notice I didn't write the code before I'm doing this tutorial. Okay, so let's jump to doing the, like, for other, just the basic operator, it is the same thing. So this is the multiplication operator, and you specify what's on the left-hand side, right-hand side, and you do the calculation. But in this case, the problem is that if we multiply two linear equations, the return will not be a linear equation the way we've represented it, because we'll have an X squared in there. So that's why we're skipping it. But in terms of syntax, it's exactly the same as we did for these. Now, what we're going to do instead is overloading the plus equal operator, which will add something. So in this case, for example, I can do result plus equal G. So this will add G to result directly. So let's overload this operator. Now, how are we going to do that? So we know that it should return a linear equation. We'll also specify the operator similar to how we did before, plus equal. The right-hand side is also a linear equation similar to how we did before. Okay, now how do we, like, what do we return in this case? So what is different now about what we did with the addition? Before, we were creating a new object of linear equation and we were returning that. In this case, what we want to do is we want to add this values of this linear equation to our existing one, to the one we are inside right now. So what I will return here is a reference object and not a new object. Like at the end, we will just return a reference to the object we are in. Actually, let me start with a simpler. Let's say this is void. Okay, let's say I'm not returning anything because I just want to add the value of the right-hand side to my existing object. So, I mean, the way to do this might be like A equal to A plus right-hand side, even better, like plus equal right-hand side A, and B plus equal right hand side B. Does everyone agree with this part here? Or anyone have any questions about this part, how we're overloading this operator plus equal? Okay, let's see if it works, and then let's see if it has any problems. So let's evaluate this result plus equal G. So we will start with result here should be, let's simplify this example and just have result be a new 1, 1. And we are adding G to it. So it should become 3x plus 4, if I'm not mistaken. I'm going to add a breaking point here. And let's run this and see what do we have inside results. So this is results. And we have 3 for A and 4 for B. So our operator is working. Now, here's the problem, which you might not see. In C++, when we have an expression like this returns something. In our case right now, what does it return? It returns nothing. It returns a void because this operator is not returning anything, and it has the type of return void. However, let me show you just a simple example and show you that this actually returns something. So let's say I have integer n equal to 2, and I am doing n plus equal 2. Okay, so this is similar to here. Now let's say I do C out, for example, of this right here. If I'm doing a C out of this part, what should I see as output? Probably 4. And we do C4. What does that mean? Like, if this was exactly a similar operator overloaded to ours, n plus equal 2 should have returned nothing. And whatever was the output of this expression should have been void. And therefore, it couldn't have printed any value. And this is where we have something wrong here. So whenever you're overloading an operator like this, which handles, like it changes things, it changes the object itself, at the end, it should return a reference to itself. In other words, right here, if I do results plus equal G, and I call evaluate on this return, this gives an error. Expression must have class type. This expression does not return anything. So whenever we're dealing with an operator that modifies the object itself, at the end, it has to return a reference to itself as well. So that if it's being used again after the expression happens, it will be able to access that, that reference. So what does that mean? The return type here will be linear equation reference. And what we will return at the end is a reference to this object, which is the one we are inside right now. Which is similar to what's happening here when we're using plus equal on an integer, and then we are using this expression that is passed to the OSTream operator that is expecting here an integer. If this operator, the inside expression was returning void, returning nothing, then the cout would have seen void and it couldn't have output anything. But what this expression is returning is a reference to the variable itself, n, after it does the summation. And this is exactly what we're doing here. So after we do the changes to our object of linear equation, and we are adding to it whatever we're passing to the right-hand side, we are returning a reference to this object. So can we do this now? So after resolving this expression, the inside expression, the return will be the result object, a reference to the result object, which means now I can call evaluate on this resulted object, which we couldn't do before because the return of this expression was being void. So this is very important whenever you're overloading operators that will that basically do not need to return anything. When you don't need to return anything, meaning that in this case we are changing the object itself, we're modifying the values and that's it, you will have to return a reference to the object itself. Any questions? Did everyone get this part? Okay. So now let's say we want to print the equation. Let's say I want to be able to print any equation, any object. I mean, we can define a function called print. And define what to print and then make the call on the function. But what would be better to do is that can we overload this operator right here? This is an operator of type OSTream. And you can see that like all of these that have, like we can just pass them to here, basically have an overload for this operator that defines how to print things. So we would like to do the same thing. We would like to do cout of result, for example. Right now, it will tell us that operator, the output operator matches, there's no operator that matches these operands. So for the OSTream, like on the left-hand side, there's an OSTream object, which is a cout. And on the right-hand side, we have a linear equation object. It doesn't know what to do. And this is what we need to define now. Now, the thing is, in this example, or in this case, this operator, the left-hand side is not an object of linear equation. So our operator will not be a member of our class. It has to be a global operator overload that on the left-hand side takes, basically takes an OSTream object, which the cout is of type OSTream. And on the right-hand side, it will take a linear equation object. And then it will define what it does. And if you remember when we discussed friend functions and friend classes, I told you at some point we will see the only maybe example that you'll ever see that uses friend functions, or the one that is meaningful in the examples that you see, because there's a lot of examples, but like you should always ask, like, why the hell do I want to do this? This is one of the examples in which it makes sense to use friend functions. So basically, we will declare our operator globally. So I'm outside the scope of my class before the main function, and I will declare my operator operator, this the output operator, and on the left hand side it will take an OS stream by reference. We'll call it OS output stream, and on the right hand side it will take a linear equation object as constant reference as well. We'll call it the right hand side equation. And now we will define what it does to output this. So I'm going to use the OS here. Basically, this will be the cout, for example, or later on in this course, you will see how to deal with files. But this OS will be the cout, so I can use it like this. And then I will specify I want to output the right-hand side A and times X plus right-hand side B. And now I have a problem. I cannot access A and B because they are private members. And this is a global operator. So this operator is outside my class, this class. And I cannot access private members A and B. This is where friend function, like declaring this as a friend function, will make a lot of sense. This is not a function part of my class, but I will declare it as a friend function in which it will have access to my my members, my private members, but it is not part of my class. So yes, I'm putting it inside the class because this is how you declare a friend function. But this function, this operator overload, is a global operator overload, and it's not a member of my class because I'm using the word friend. It is a friend operator being overloaded, but it is a global one. And what it does now in here, it takes on the left-hand side the OS stream object, which is cout is one of them, or cout is of type OS stream, which is the output stream class inside the standard library. And on the right-hand side, I have my linear equation in which we are also having it as constant reference. I think this can be constant. We're not modifying OS. Okay, no, we cannot have it as constant. Okay. Now let's try to use this operator. Let's try to output the result, which we have it right here, and it stopped making a mistake. It's not an error anymore. It is valid. Now it sees this operator. We can read here, this is our operator. It has a return void. It's operator for the output. It takes on the left-hand side an OS stream object, and on the right-hand side, a linear equation object. If you hover over cout, you can see that it is of type OS stream, which is part of the standard library, and our result is of type linear equation. So we're gonna run this and see if actually we get an output. Not sure what's happening. Okay, we do get an output. I think the first 4 is coming from here, okay, and it is 3 times x plus 4. So let me remove this output here. Okay, let's look at what we have here. So we're having result starting as 1x plus 1, and then we are adding to it the g, which is 2, 3. So we should have 3x plus 4. And we are outputting result, and we do see 3 times x plus 4. So our operator to output is working, which is great. Anyone have any questions? Are you guys following up with what I'm explaining? Okay, now let me ask you this. When you're dealing with this output, usually from what you've seen so far throughout your C++ experience, we can do like output n, for example, n is the integer variable we create here, and then output some string, hello, and let's say then we output result. Okay, let's run this and see what happens. Okay, this breaking point is making things not show. Okay, so I have the output of 2, hello. 2 is the value of n, which is an integer, and then hello, new line, and then the output of result, which is 3x plus 4. Great, everything is working beautifully. Now, what happens? What should we expect the output to be if I, let's say, put the result here and put the n here or whatever? I'm immediately seeing an error. If I just have this, everything works fine. If I, after this, extend it to also output n, for example, now things are causing problems. But if I switch the n and the result, everything works fine. What do you think is the problem? I have a hint right here. This is the operator. Let me remove this result. This operator right here is similar to the operator we've overloaded. The difference is that on the left-hand side, it's an OS stream, same to ours, but on the right-hand side, it's an integer, type int, and not linear equation. Let's look at the declaration of it. What's the type that it returns? It returns an OS stream by reference. On the left-hand side, it takes an OS stream object. On the right-hand side, it takes an integer, but it returns an OS stream object by reference. What does that mean? It means that after we evaluate this expression, the return after that is also an OS stream object. So if we do this, this part here by itself means nothing. So let's just do this here. So n and the operator, which is the output operator with the hello, it doesn't do anything because there is no operator overload where the left-hand side of this operator is an integer and the right-hand side is a string. But if we do cout n and then hello, this expression right here by itself is being evaluated, and then it is returning an OS stream object, which then is being used as the left-hand side, and the right-hand side would be hello. So in other words, let's look at our operator here. This operator is, but after it's doing all the calculation or whatever it's doing to output the value, it is not returning anything, and the return type is void. So when we have here cout result, this will be evaluated, but then this will return void as an expression. So if I output the n, the left-hand side now of this operator is void, and the right-hand side is an integer. What I would like to achieve is that the left-hand side of this will be the C out again, will be the OS stream. So how do we do that? Like I want to, after I've used the C out, to return it again so that anything that comes after this expression is evaluated, we'll see on the left-hand side the C out, or the OS stream in this case. And this would be done by simply, instead of returning a void for this operator, we will return an OS stream reference. And after we are done with this OS, this is OS which is passed on the left-hand side, which in this case is the C out. What we will do is that we will return this OS. So after I'm done using the C out, or the object of OS stream, I'm going to return it. So whatever expression comes afterwards, we'll see that C out, and then it will become the left-hand side of it. In this case now, this will now return the C out again, because this was the OS that was passed to the first operator that was expressed. And when it was done expressing this result, outputting the AX plus B, it will return C out again. So the result of this expression will be the C out, which will be used as the left-hand side for this operator, and the right-hand side will be the integer, which now will be evaluated. I have many outputs here, but this is the last one, 3x plus 4 and 2, which is this statement right here. Okay, who didn't get this part? Which way? This way? The thing I have right here? Okay, let's go back and see that it wasn't working. So before I had a return here of void, and I was just expressing the print and not doing anything afterwards. This expression was returning void. And this is causing an error here. Expression must have integral unscoped enum type. The error is not very meaningful in this case, but this will not even compile. It's saying that there's an illegal, this error is more meaningful. It's saying that there's an error for this operator. It's illegal. The left operand has type void. So this right here, this part right here, the left operand of this operator has the type void, and the right one has the type integer. So the error is saying I cannot do anything with this operator where the left-hand side is void, because this expression right here that we have overloaded is returning void. It's taking on the left-hand side an OS stream, on the right-hand side a linear equation object. No, also it wasn't working. It's the same thing. The parenthesis is just to show you like how it's the syntax working. But this is also will not work. This part here will not return anything. So the left-hand side of this second operator will be void, and the right-hand side is integer. And if you have a left-hand side of void, which is returned by this expression, it cannot output anything. Like it doesn't know what to do with the void with this operator on the left-hand side. This is why after we're passing here the C out, left-hand side of this operator, right-hand side the linear equation object. After we finish using the C out, this expression needs to return the C out again, so that the second operator will see it as the left-hand side. Is it clear? Okay, so now if I change this back to returning the OS stream, which we are passing on the left-hand side. So I'm basically taking it, using it, this OS, which is the C out in this case, I'm using it, and then I'm returning at the end. Now, after I'm returning it, this expression will return the C out again, which will be used as left-hand side for this second operator. Is it clear for everyone? Okay, so if this is clear, we're gonna move to Boolean operators. If this is not clear, let me know now so that we can redo it or something. Okay, so now let's say we want to check if f is equal to g, for example. We want to be able to do something like f is equal to g equal. And we're getting an error saying that the operator equal does not, there's no operator equal that matches these operands, which is the left-hand side being linear equation and the right-hand side being linear equation. Similar to how we've seen all of those other operators. So let's do it here. Let's overload this operator. Linear equation operator. So this is the return. Actually, what should the return be here? What should the return of this equation, this operator be? Not true, but bool, true or false. It should have the type of boolean. So operator equal equal, and this is a member operator of our class. So the left-hand side will be this object that we are inside. So we'll only add the right-hand side. And now how do we do the comparison? So let's say return A is equal to right-hand side dot A, and B is equal to right-hand side dot B. So if the A's are equal and the B's are equal, then this will be true. If one of them is false, then the whole expression will be false, and it will return false. So now this operator, yeah. So when you're declaring the type of the return, it has to be a type. So if you're returning true or false, it will be bool. If you're returning a number, integer, it will be int. When you're dealing with Boolean expressions, your return is usually a bool. So now looking at this if statement here, we're still having a problem. Which, okay, it wasn't a problem. It was just the IDE not loading things quickly. So in here, we're saying if f is equal to g, output equal, let's say else not equal. We run this example, and we have not equal being output. Actually, at this point, we can like write nice output. So let's say cout f, and we will output f because we've overloaded the operator for outputting, and then g. We'll also output g, and then we will output if it is equal or not equal. And I'm going to remove this output at the end. So this is our f, it is x plus 2, and our g is 2x plus 3, and they are not equal. Okay, now let's, did everyone get this part? So for the rest of the operators, it follows the similar thing. So let's say I want to overload the operator of not equal. It also takes constant linear equation by reference. Now the thing here that I can use the equal operator because I've defined it. So let's say I have return dereferencing this object. So let's say I have not this equal right hand side. This should work. So what I'm doing here is that this is dereferencing this object, so it should return a reference to the object I am inside right now. And I am using the equal operator that I've defined above to say that this object equal to the right-hand side, which will basically return this expression right here. And then I'm saying not. So the opposite of equal. Really, that's it. So not equal. Okay, let me keep this because I want to run another example with the equal. But let's say not equal. So if f is not equal to g, we're going to output not equal. And if they are, so if this is false, it means they are actually equal, and we will see an output of equal. But before, like after this, let me change f and g, maybe make g. So g is 2 and 3, f is 1 and 2. Let me add to f, for example, let's make them equal. So 1 and 1. This should make us equal with g, I believe. Okay, so first we're getting not equal, and then we're getting equal because we did the modification, which is good. Let's output things again. Okay, so first we have the x plus 2 and 2x plus 3, they are not equal. Then we have 2x plus 3 and 2x plus 3, which are equal. If you're overloading the other operators less than and greater than, I actually don't really know what they would mean in linear equations. So if there is no meaning for them, like you shouldn't overload them, obviously. Like there is a meaning with lines if they are parallel. Maybe like one line will be under the other and one would be above the other. But if they are intersecting, I'm not sure what to do with that case. But maybe you can design something that works for you. But we're not going to overload those operators now. But anyone have any questions about everything we just covered? Because I want to go through one last example that will probably be a cool one. Okay. So if no one have any question, comment all of this. Even go. I'm commenting things just to share with you the code afterwards, so you don't lose it. But I will recreate these. So I'm back with my f and g here, and actually even just let's call this equation z. Okay, it's 1 and 2. Can I do this? am I allowed to do this? So my left-hand side is a linear equation object, which is Z, and my right-hand side is the number 2. So someone is saying no, and someone is saying yeah, and I believe the person who's saying yes is saying yes because the IDE did not tell us we have an error, which is a strange thing. We've defined the Boolean operator, this one, the equal operator, to take on the left-hand side a linear equation and on the right-hand side also a linear equation. So how can it know what to do if we are passing an integer or a number on the right-hand side? Let's try to see what operator is being used here. So if we hover over the operator, it's actually using the operator that we've defined. We've defined the operator that takes on the, it's an operator of the object itself, which is on the class of linear equation. And it takes on the right-hand side also a linear equation. But this is a number. And this is what's happening here. So if we go back to our class, we have a regular constructor here that takes 2 arguments, double A and double B. However, the double B is by default 0. So what's actually happening right here is that the compiler is implicitly constructing an object of linear equation, passing 2 as the argument for A, and B will have a default value of 0. And in here, it will be constructing a linear equation object, and it will be using this operator. I don't know if you got that, but if we actually run this, it will say not equal. And this is not comparing Z, linear equation object, to the integer n. It is actually casting this integer to an object of linear equation by making a call to the regular constructor. This regular constructor, it is passing the 2 for this A, and the B by default is 0. So it is constructing a linear equation object of A being 2 and B being 0. And then it is using the Boolean operator to compare a linear equation object with a linear equation object. So this, in this case, does work. How about this? Is 2 equal to Z? We can already see that we have an error, so it's not working. And the problem here is that this operator now is being the type of operator on the integer. So it's the overloaded operator on the integer. And it does not see a way to, like there is no overloaded operator that takes left-hand side integer and right-hand side a linear equation object. And there's no way for the compiler to implicitly cast the linear equation object to an integer. Before we define or overload this operator, I would like to go back to here. We're saying here that the compiler is implicitly casting this number, this integer, to an object of linear equation. How can we prevent the compiler from doing something like that? Maybe we don't want it to do something like that. So you shouldn't know this answer because I'm assuming you've never seen this before. But basically, the compiler is using this constructor implicitly. By itself, it's saying, I have a number here, I have an integer which can be casted to a double, which means that I can, from that integer, construct a linear equation object which will work with that operator. So it's implicitly using our constructor. without us saying, I want to construct an object of linear equation. And what we can do is that we can use the keyword explicit. And now we are declaring that this constructor can only be used explicitly by us. It cannot be used implicitly by the compiler. We're declaring this constructor to be explicit. Now, if we go back to this example, now we have a problem. The problem is saying that there's no match for this operand in which on the left-hand side is a linear equation and on the right-hand side is an integer. Because now the compiler is not allowed to make an implicit call to the constructor of linear equation and is not allowed to construct an object by itself from this integer. What do we mean by explicit? It means that this cannot be happening implicitly, but we can still do an explicit cast. Static cast maybe. We are still allowed to do a cast. Us deciding, the programmer deciding that here I want to make an explicit casting from this integer number to a linear equation object. Okay, who got confused even more? So this will not work because now we've declared the constructor of linear equation to be explicit, meaning the compiler cannot make an implicit casting here from an integer to a linear equation object, and we do not have an operator overloaded that specifies what to do when we have left-hand side being a linear equation object and the right-hand side being an integer. If we not make this explicit, this will work. The compiler here will implicitly make a cast from this integer to a linear equation object, and then it will use the operator that we've defined in which it takes left-hand side being a linear equation object and the right-hand side also being a linear equation object because the compiler changed this to a linear equation object. Now, why this doesn't work? This doesn't work because this operator now is an operator on an integer. The left-hand side is an integer, and it does not know what is an integer operator that takes, like the compiler does not have a definition for an operator that takes left-hand side integer and right-hand side in this case, a linear equation, which we can define it. We'll do it similar to the friend class here. It doesn't because like someone's asking why it doesn't automatically cast it in reverse even though it's implicit. Because right now here it's trying to find an operator that might work. And the operator we have defined takes on the left-hand side, it's an operator of type of this class. This operator here is an operator on the linear equation class. So the left-hand side has to be an object of linear equation for it to be used. So if the left-hand side is an integer, it is not going to search for operators inside the linear equation and see, can I use it? Because the left-hand side is just different. It's an integer. It will not cast whatever is on the left-hand side. Like it cannot even see that operator yet because you're not using it on the right object. But when it is when Z is on the left-hand side, now this operator is defined. So it starts with the object of linear equation. It sees what operators we have overloaded. It finds one in which the right-hand side is a linear equation. And then it starts asking, can I cast this to a linear equation object? And the answer is yes. And the other way around, it has no idea what to do when the left-hand side is an integer and the right-hand side is a linear equation. But now we can, it has to have a left-hand side of linear equation to use this operator, where is it, this operator, because we have defined this operator to be a member of our class. So you can notice here, we are only passing the right-hand side. Everything else, like we're using the A and B of this class. For the example of the OS stream operator, this is not a member of our class. This is a global operator in which we are defining the left-hand side and the right-hand side. And we are declaring it as a friend function just to be able to access the private members. But it is not a member of our class. Now, how can we declare an operator in which the left-hand side is an integer and the right-hand side is a linear equation? Similar to how we did this friend operator, we can cast it ourselves. Yes, of course, we can do here a cast, like static cast. And we can cast this to a linear equation object. And now this linear equation object will be using the operator that we've defined before. But we actually want the compiler to have a meaning of comparing integer to a linear equation object. And we will define this operator now here. We will basically say, it will not be an operator as a member of our class. It will be a friend operator, because now we are defining the left-hand side and the right-hand side. The return will be a bool. It will have to be a friend function because it's not part of our class, but it will have access to our private members. Operator equal. The left-hand side is an integer, and the right-hand side is a linear equation by reference. Okay, I have some problem somewhere. Oh, I have a typo on operator. Okay. Okay. So now this is a bool operator, a friend to our class. It takes the left-hand side to be an integer n, and the right-hand side to be an object of linear equation. And now we can define what do we return. So return, let's say b, or we don't know what b is. We have the right-hand side b is equal to 0. Actually, what do we mean by? Okay, there's another thing here that we did not. When we have this implicit cast, this is actually a wrong comparison. This is actually a wrong comparison, because the default value for b is being 0. And whatever that too is being passed to the x as the a. So what we're comparing here literally is, instead of 2, we're comparing 2x. So what I would like see is best to happen is that this 2 will actually mean 0x plus 2 and not 2x. So this implicit meaning is even wrong. Anyway, this operator we have here, let's say if right hand side A is equal to 0 and right hand side B is equal to n. So this will maybe make sense to be equal comparing to an integer if the uh, left hand side, if A is 0 and we just have like a straight line with 0 slope. Maybe this will make sense. But again, it's just a class that we're creating right now. But anyway, this will allow us to compare things like this. This will allow us to use an operator in which the left-hand side is an integer and the right-hand side as a linear equation object. We can test this. So let's say we have 0 and 2. Are they equal? And yes, they are equal. Okay, do you guys have any questions? If I flip it again, yeah, I believe it will show not equal. It should. It's basically making a cast here to a linear equation object in which is taking the 2 as the A. So now we have as if like 2 and 0. If I flip them, it should be not equal, which is something that would be a bug that you might not notice even that exists. If I make this explicit now in here, this will not be allowed anymore. Or it shouldn't be allowed. This shouldn't be allowed because right now it's trying to do left-hand side being linear equation and right-hand side being an integer, but it does not have that. We do not have an operator that takes left-hand side linear equation and right-hand side integer. What we have is one that takes left-hand side integer and right-hand side linear equation. So if we want the other way around, we'll have also to define it operator equal equal. Left-hand side will be linear equation. And right-hand side will be an integer. And what we can return here is we can just flip them. Because we have a meaning of n being on the left. So now the return of this will be just the equal but flipped. So this now should work. And it does say they are equal. Now, by the way, I declared this as a friend, which is not a member of my class, which I am allowed to do. But you can also, because the left-hand side is this equation or like this object, you can also define it as a member of this class. Like it will be something like this. So it will return a bool. And what it will take on the right-hand side is the n. And it will be like return n is equal to, we can do this. Because we have this operator right here and we can use it. Also says equal. Okay, we're running out of time. Maybe next on Wednesday we'll do more examples, because there are also other operators that will be interesting to discover. For those that do not know, new and delete are operators and not functions or something. They are operators, so we can even overload these operators. Size of is an operator and not a function, so we can also overload this operator. And even the function itself, or the class itself, can be an operator, meaning so what do I mean by that? For example, and here we said evaluate, but let's say I want to have a more mathematical, like to be able to use z as a function by itself. So let's say this, okay? So I want this to be equivalent to z evaluate 2. The object by itself can be an operator that we can overload, and let's do it right now. So the return in this case will be a double, and it will be the operator, the function call on the object itself, and what it will take is the double x, and this will be a constant operator because it is not changing anything in the object. So actually, every operator that we've defined that is not changing the class or the object should also be a constant operator. But in this case, we can make a call to evaluate because we already have that defined, and we can just return the value of evaluate. Okay, this is not working because evaluate is not constant, but we can make evaluate constant, which we should have. So now it's working. If we go back to this example, now we should be able to make a call on the function itself. So like cout z2. So z2 will give us the same, is using an operator, which is the function call on the object. And this will, in our declaration, will return the evaluation of 2, which is having a value of 2 as well. Should it have value of 2 as well? What's z? Let's see what's z. Now we can do all of this. We can see out the object z. We can add to that cout a string, and then we can make a call to the operator of the function call on z itself, which will call the evaluate function with x equal to 2 in this case, and it will return a double, which will be the right-hand side of this operator, in which it will output to the console. Our equation is 0 times x plus 2, evaluate x equal to 2, the value is 2. So in this case, regardless of what we pass to x, it will be 2. The answer will be 2 because a is equal to 0. Let's do z plus linear equation 1, 1. Okay, z plus equal linear equation 1, 1. And now we evaluate this. Now z is 1x plus 3. Evaluating x equal to 2 is 5. So 2 plus 3 is 5. Any questions? I think we ran out of time. Maybe first time we run out of time. Okay, I still have like 5 minutes, which is good enough for the attendance.